Right now, most robots move with rigid motors and gears. But what if robots could move like us, using soft, flexible muscles woven right into their structure? That's exactly what a new technology called electrofluidic fiber muscles is trying to do. In the next 4 minutes, you'll see how these tiny fiber-shaped muscles work. You'll also see why they're so powerful, and you'll see where they might show up in the real world. Electrofluidic fiber muscles are soft, fiber-shaped artificial muscles about 2 millimeters thick. That's roughly the width of a pencil lead. They are designed to act like biological muscles. They contract, relax, and generate force when you send electricity to them. Instead of gears, they use tiny fluid-filled channels inside the fiber. They also use silent electric pumps to move liquid from one side to the other. This liquid movement makes the fiber shorten or bend. Inside each fiber, there are two opposing fluidic actuators in a closed loop. When you power the muscle, electrohydrodynamic pumps shift fluid from one chamber to the other. These pumps are thin tubes that push liquid using electric fields, with no moving mechanical parts. This inflates one side, shortening the muscle. At the same time, the other side deflates, helping it extend. Because the system is closed and self-contained, it doesn't need an external tank of liquid. It also doesn't need a noisy compressor. It's electrically driven, silent, and can run completely untethered from a battery. Despite their thin form, these muscles are surprisingly strong. They achieve a power density similar to human skeletal muscles. That's around 50 watts per kilogram. They can contract by up to about 20% of their length. This contraction happens in under 0.3 seconds. Researchers have bundled several fibers together to create a compact muscle. This bundle can lift up to 4 kilograms. That's about 200 times its own weight. Yet it still stays flexible and lightweight. That combination of strength, speed, and softness makes them perfect for robots that need to safely interact with humans. Because these muscles are fiber-shaped, they can be woven into fabrics. They can also be bundled like real muscle fibers. Teams have already integrated them into robot arms that bend smoothly. These arms can bend up to about 40 degrees, yet they remain compliant enough to safely shake a human hand. They're also ideal for wearable assistive systems. Imagine a soft sleeve that quietly helps your arm move during physical therapy. Or imagine a smart garment that gently supports your back while you work. Unlike bulky motors, these fibers can be built directly into the textile. This makes the whole system lighter and more natural to wear. Right now, electrofluidic fiber muscles are still in the research phase, but they've already shown they can power fast levers. They can also power strong lifting bundles. And they can power soft bending joints. As this technology matures, we could see them in medical robots and rehabilitation devices. We could also see them in agile untethered robots. And we could see them in smart clothing that literally moves with you. So the next time you see a robot that looks and moves more like a living creature than a clunking machine, it might just be powered by strands of electrofluid fiber muscles inside.